the second unit of software engineering, that is software project planning. In this lecture, we are going to see what is software project planning and its objectives and various estimation models and software equation. Software project planning. Software project management begins with a set of activities that are collectively called project planning. Before the project can begin, the manager and the software team must estimate the work to be done and the resources that will be required and the time that will elapse from start to finish. This is called software project planning. Objectives. The objective of software project planning is to provide a framework to make reasonable estimates of resources, cost, and schedule. These estimates are should be updated regularly as the project progresses. In addition, estimates should attempt to define best case and worst case scenarios so that project outcomes can be bounded. The planning objective is achieved through a process of information discovery that leads to reasonable estimates. Next is estimation. The project planning involves estimation. Estimation is attempt to determine how much money, how much effort, how many resources, and how much time will take to build a specific software-based system or product. Next is estimation techniques. There are various techniques to estimate the project planning. Here we are going to see two broad categories: problem-based estimation and process-based estimation. In problem-based estimation, we are going to see LOC-based estimation and FP-based estimation. In process-based estimation, we are going to see about COCOMO model. Problem-based estimation. In problem-based estimation, the problem is divided into small problems. When all the small problems are solved, the main problem is automatically solved. There are two types. One is LOC based. LOC is line of codes, and FP based, that is function point based. LOC line of codes, FP function point estimate methods consider the size as the measure. In LOC, the cost is calculated based on the number of lines. In FP, the cost is calculated based on the number of various functions in the program. Next is FP. The idea of function point is to identify and quantify the functionality required for the project. The idea is to count things in the external behavior that will require processing. The classic items to count are inputs, outputs, inquiries, internal files, and external interfaces. This table represents the function point model. In this function point model, we are calculating the information based on number of inputs, number of outputs, number of inquiries, and number of files, and number of external interfaces. Based on these information, the various estimations are calculated, and FP count is calculated. And finally, the total count is calculated. The steps of FP model is: first it measures the parameters such as input, output, inquiries, files, and external interfaces. Then assesses the complexity of the values for each of the information, and then calculate the raw FP. Here We are calculating FP count for the corresponding information. Rate the complexity factors to produce the complexity adjustment value. Then we are calculating CAV, complexity adjustment value. Final step is to calculate the adjusted FP. The adjusted FP is calculated by means of this formula. Next is process-based estimation. Process-based estimation identifies the set of functions that the software needs to perform as obtained from the project scope, and also needs to identify the series of framework activities that need to be performed for each function. It also estimates the effort that will be required to accomplish each software process activity for each function. It applies average labor rates to the effort estimated for each process activity and also compute the total cost and effort for each function and each framework activity, and then compares the resulting values to those obtained by the value of the LOC and FP estimates. If both sets of the estimates agree, then your numbers are highly reliable. Otherwise, conduct further investigation and analysis concerning the function and activity breakdown. This table shows process-based estimation. Here we are calculating different functions. Corresponding estimations are calculated, and then total is calculated. Finally, the total effort is calculated. Here CC is the customer communication and CE is the customer evaluation. Next is COCOMO model. COCOMO model stands for Constructive Cost Model. The COCOMO model is a single variable software cost estimation model developed by Barry Boehm in 1981. The model uses a basic regression formula with parameters that are derived from historical project data and current project characteristics. The hierarchy of COCOMO model are various types of COCOMO model are basic COCOMO model, intermediate COCOMO model, and detailed COCOMO model. The basic COCOMO model is good for quick, yearly, rough order of magnitude estimates of software costs. It does not account for differences in hardware constraints, personal quality and experience, use of modern tools and techniques, and the project attributes known to have a significant influence on software cost, which limits its accuracy. For the intermediate COCOMO model is a basic COCOMO model a starting point. It starts with basic COCOMO model and then it identifies personal, product, computer and project attributes which affect cost and development time, and then multiplies basic cost by attribute multipliers which may increase or decrease cost. The detailed COCOMO model incorporates all the characteristics of the intermediate version with an assessment of the cost drivers' impact on each phase of development process. This helps in determining the manpower allocation for each phase of the project. The phases are the requirements and product design. Under requirements and product design, plans and requirements and system design is calculated, and then detailed design is calculated. Finally, the code and unit test is performed. Next is software equation. It is a multivariant model and it has been derived from productivity data collected for over 4,000 contemporary software projects, and it is shown by an equation. Here the equation software equation E is equal to LOC into B power 0.333 divided by P power 3 into 1 by t power 4. Here E represents the effort in person months or person years. T represents project duration in months or years. B represents special skills factors. P represents productivity parameter, and these reflects other process maturity and management practices. The extent to which good software engineering practices are used, the level of programming languages used, the state of the software environment, the skills and experience of the software team, the complexity of the application. That's all with the Unit 2 in software engineering. Thank you, Ananda.